Hi, my name is Joseph, and I'm going to explain how a linked list can be used internally to implement both a stack and a queue, along with the time complexity of the main operations. So, starting with implementing a stack with a linked list. A stack follows the last in, first out rule, meaning the last item pushed is the first item popped. To implement a stack using a linked list, I would treat the head of the list as the top of the stack. Now for the push. To push an element onto the stack, I insert a new node at the head. This is efficient because it only requires changing a couple of pointers and has a time complexity of a big O of 1 operation. Now for the pop. To pop, I remove the node at the head of the list. Again, no traversal is needed, and so a time complexity of big O of 1. Next, we implement a getTop. To get the top element, I simply return the value stored in the head node again, a time complexity of big O of 1. Now for an isEmpty. To check if the stack is empty, I check whether the head is null, which is still a time complexity big O of 1. Now for implementing a queue with a linked list. A queue follows the first in, first out rule, meaning the first item added is the first item removed. To implement a queue with a linked list, I would maintain both a head pointer for removing elements and a tail pointer for adding elements. So let's start with an enqueue. To enqueue, I insert a node at the tail. Since I already have the tail pointer, I don't need to traverse. This would be a time complexity of big O of 1. Now to dequeue. To dequeue, I remove the node at the head. This removes the oldest element, a time complexity of big O of 1. Next to the size. To get the size efficiently, I would maintain a counter that updates during enqueue and dequeue. That allows size to be returned instantly and is a time complexity of big O of 1. Without a counter, it would require a traversal and become a big O of n operation. Now for an isEmpty. To check if the queue is empty, I check whether the head is null, which is a time complexity big O of 1 operation.